Hey everybody, welcome back to our podcast. I'm your friendly General Counsel Patrick Tan from ChainArgos. With me every week, as usual, our CEO, Chief Data Scientist Jonathan Reiter. Thanks for tuning in. Thanks for joining us. Thanks for all your likes, comments, and subscriptions. I do apologize. There's a whole bunch of comments we've yet the AI has yet to get to. So once the AI comes back from their break, they will get back to those comments.
Or you could just comment on the Twitter account that somebody watches as per the PSA last time. Anyway.
So a couple of housekeeping things that we want to get straight on this episode on stuff that we said in the last episode. So we do apologize. The last episode we said that the Wasabi wallet guys got arrested.
We mixed up
Wasabi and Samurai.
Samurai wallet.
Now, in our defense, they're both Japanese themed.
Well,
so
we mixed them up only partially. So the issue is that it was the Samurai wallet guys that had been arrested and whose servers were shut down. But beyond that, Samurai wallet exhibits
Wasabi wallet
exhibits many of the same features as Wasabi wallet. There was a centralized service that had to get cut out, and somebody decided to stop running it, and all these things. So the sort of software, legal, conceptual issues are all the same. We just misspoke, really.
It's like MathNet, the names are made up, but the problems are real.
Oh, there you go. Yeah, okay.
Yeah, so in this case, we didn't make up the names, because just for the record, the Wasabi wallet guys, I'm getting this right this time.
There's no arrest there at all.
There were no arrests there at all. They did stop their services.
They
changed some stuff up when the Samurai wallet guys
soon after
the Samurai wallet guys got arrested, which is always a good sign. Like, if you've got your chicken and rice place on the same street as the next chicken and rice place guy, and you see the cops busting up your neighbor's chicken and rice place, you should probably close up and
criticize people learning from mistakes is a positive thing. Anyway, all right.
So anyway, what are we going to talk about this week? We've got an interesting show for you today. No data, but we've got props. So we're going to talk about Celsius Network and some of those clawbacks, which, surprise, surprise, if you've been a fan of the show, we've spoken about for a long time. So a lot of stuff is that we've talked about in the past.
Celsius Network Ponzi-related clawbacks I'd been commenting on before Celsius Network filed for insolvency.
Yeah, that's how vintage this stuff is, so you're getting all the good stuff. Let's talk about Celsius Network. We're going to talk about not conceptual. We're going to help explain and help people to understand, by way of props, what's the difference between open source and closed source, and what does it mean when some stuff is kind of like a hybrid, because open source and closed source are pretty well established, not just computer science concepts. They've been litigated. These have actually been litigated concepts in court to establish what is open source and what's the extent to open source.
There's licensing agreements.
And there's licensing agreements and the rest of the stuff. So then we're gonna cover that somewhat. It's not gray. It's just that people don't fully understand it. And the problem with this space is that it's full of nomenclature, and that helps to confuse people even more. But what is it? Basically, long story short, smart contracts.
Right.
Decentralization and open source, closed source. Okay, then we're going to talk about that. And then finally, we're going to talk about WazirX, which is the crypto exchange from India that suffered some kind of an exploit and is alleged to have been taken for about 235 million worth of crypto and a whole bunch of tokens and stuff like that. We talk about one of the possible things that could have happened there.
Or at least what we can learn from the experience.
And what can we learn from the experience? Right. So let's talk about Celsius Network. This is your pet topic, John. And there's a whole bunch of clawbacks. We looked at some of the claims. That's pretty wild.
Yeah. Okay. So we're going to assume here that as far as bankruptcy law is concerned, Celsius Network was in reasonable part a Ponzi scheme. I have publicly said before, I don't think it really qualifies as a Ponzi scheme because they did have an underlying business, but they were still primarily paying old returns out of new investments. So it certainly qualifies under the bankruptcy code for clawbacks and sort of an equal distribution of whatever asset recovery. The principle in U.S. bankruptcy code here is that if the business was a Ponzi scheme, or in large part a Ponzi scheme, whatever, that the creditors who took out, so people who are owed money need to be restored to an equal footing with people who net made money, since if there was no underlying investment, it's all just reallocations of people's initial investments in the first place. The best known example of this is the Bernie Madoff thing, where they clawed back huge amounts of investment returns from some investors and redistributed them to other investors. The idea being that everybody should get back give or take the same recovery as a function of how much they put in, because the money was never invested in any underlying enterprises that could have made or lost any money. To the extent that Celsius had underlying business investments, I mean, Madoff had some underlying business investments. I would argue that Celsius was actually operating a borrowing and lending business, even though it was a money-losing and not very well-run borrowing and lending business, whereas the Madoff investment scheme consisted almost entirely of a bank account that did nothing. But the threshold is not that definition of Ponzi scheme. It's not the moral definition. So the lawyers are now going through the process of suing people who took out more money than they put in, and suing anybody they think they can get some money out of, which is the way lawyers work in the United States. So among the other more entertaining lawsuits they're suing Compound for having liquidated them on a loan in 2020 as a result of a Oracle price error. So the price source had a mistake, and they got liquidated for no reason when a stable coin went up 30%. There was an error there, somewhere, but the protocol worked the way it was supposed to work. So I think there are three things to notice here. One of them is that problem still plagues us to this day, so it doesn't seem like anyone has a solution. Spoiler alert, there's no proper solution, because this on-chain, off-chain communication, trustlessly not possible. The second one is that people are saying it's unfair because that happened several years ago. There are statutes of limitations, and in this case, that's well inside the statute of limitations for that type of claim. So had it been in the 1980s, it would not be actionable. But since it was in 2020, and for this, depending on precisely the nature of the claim, statutes of limitations for stuff like this can be 6 years, 10 years, 15 years, 20 years. They're many years. 2020 is well inside the history there. And the third one is that while it may seem unfair that people who have better financing and more lawyers get better recovery and better treatment in the courts, that is a feature of the American legal system, and that's the way it works. So you're going to get better recoveries if you can pay more lawyers to go after more people. Whether or not they filed a huge number of these things a couple days ago, whether or not most of these, any of these, all these will succeed, we have no idea. But we also know that there are many cases in which it will be less expensive for the Compound or whoever to settle in that case, while they got liquidated, they clearly. Whether the amount of the loss is meaningful, I guess we'll find out. But it may be cheaper to give them some of the recovery back than it would be to pursue the case, because the bankruptcy estate has a lot of assets, and in some sense, people have complained about this with FTX for a long time.
Yep.
The lawyers only get the fees; they don't actually get the equity in the end, so they'll keep suing. Of course, in the Madoff case, the overall fees were huge, but the recoveries were also very, very high and ongoing. So watch that space. But once again, this was not just foreseeable, but foreseen. And people who are complaining about these well-known and well-established features of the American bankruptcy system, if you gave your money to a company registered in the United States and you're unhappy with the standard features of the bankruptcy regime in the United States, that's mostly on you.
Welcome to America.
I mean, it's a centralized service registered in a state, and
it's about as American as hot dogs, baseball, NASCAR. You just have to.
I would
take
argue
your lumps.
contentious bankruptcy regimes are more American than many of those things.
All right. Okay. So next, we're going to do a little bit of I have here a glass of water. As you can see, it is opaque. This water is intended to represent closed source software. It means you can't see what's going on inside.
Code fragments, functions, applets, microservices, if anybody from that community is watching the...
So, yeah. All right. So that's closed source. I have here a glass of clear water, which is intended to represent open source software. Tell us a little bit about open source software.
Okay, so the general concept here is that if you can get a program, convert the program into machine code so the computer can execute it. Computers don't execute things that look like human language. They execute streams of numbers. And as was worked out originally by IBM with Fortran in the 1950s, it makes more sense to provide people with more human language-like ways of describing computer functions, computer programming languages. Fortran was the OG on that one. And then those things get fed into a other computer program compiler that generates executable code. That process is generally one way because all of the human constructs, variable names, the comments, the structure that makes it easy for you to understand the code as a programmer, the computer didn't care at all about. The computer's given a sequence of instructions with loops, jumps, whatever, that it just follows mindlessly, because that's what computers do. And limited tools for going in the opposite direction exist, but a lot of information is lost when things are converted from source code to executable code. So open source programs are programs in which you're provided with the code yourself, instructions, whatever, the ability to generate the code, run the code, use the code. That's fine. And the issue we're going to talk about here is the interaction between systems that are partially open source and partially closed source. And the basic sort of the punchline here that we're going towards is, as long as a non-trivial amount of your system is opaque, you can't really know what's going on, because I could write 100 different functions that do all kinds of different things, and they're disconnected. And if the controller for that, for example, is something that's opaque, even by observing a couple of uses of the system, I can't know all the control paths through there, and I can't know what's going to happen.
So, and it's important that we get terms correct. And I know most of you don't make...
Closed source means that you are given... Sorry, I didn't finish the...
Yeah.
You are given the executable part
Correct.
that the computer can read.
Yes.
And we need to be very, very pedantic about this. The way that all modern computers work, the specification for the code the computer executes is public, right? ARM as a company basically only produces computer instructions and architectures for machines to interpret those computer instructions. Apple is not exactly as whatever open. ARM 64 and AMD 64. AMD 64 is the thing that you think Intel computers all run. All of those specifications are public. You can observe the binary code. You can run simulators that will execute stuff properly. The instruction set, all of this exists. You can run debuggers. It's very difficult if you only have the binary, whatever, the executable thing, the post-compilation thing, because, again, a lot of information was lost. But you have it, you can observe it, you can run Windows, and even though Windows is closed source, you can log every single instruction that's executed, all the memory stuff, everything as it runs. A modern Windows computer is probably going to generate too much for you to be able to keep track of, but you absolutely, with modern software, can run simulators for simple older computers that are significantly more powerful than the Ethereum virtual machine as implemented in a public blockchain, and log every single thing that happens. You can get Atari simulators and whatnot easily. Run all this stuff, log all this stuff. People have tried to decompile old binaries from cartridges and whatnot, right? So closed source does not mean you do not have access to binary execution traces and whatnot. Closed source means you're not given how the software actually works.
How it actually behaves. What were the sequence of things that had to happen before you get to the executable? You don't know. So
there's very little proprietary computer hardware in that sense anymore.
So it's important that we distinguish, and I know you guys don't make this mistake, but just in case, sometimes these terms can be confusing. Decentralization is not synonymous with open source.
They're orthogonal concepts.
They're not even talking about the same thing. Yeah. Like, I parked my car in the driveway and I had turkey for dinner. The two have nothing to do with each other. But there has been, as we have observed, a tendency to do word salads in this space where they combine, it has to be open source because it's decentralized. No. The two of them have nothing to do with each other.
That conflation certainly happens more often than it should. It's not always.
Not always. I'm sure you listening in and you watching the show don't make that mistake. But there are people out there who would like you to think that decentralization means open source.
So we're going to do a demonstration.
So we're going to do a demonstration.
You have a system that... Sorry. You can,
I mean, John can hold the closed source software such as it is. And he's holding that. And
so these are code fragments for which we only have the executable code. We don't really know what's going on.
And this is open source. So this is the open source part, right? So what happens if we have a hybrid...
We have a system that includes components of each.
Of each. So let's take a little bit of that closed source stuff, which we don't really know what it does, and let's put a little bit of that into the as much as we can, and let's put that in and get some of that closed source stuff.
The point is, the more there is, the darker it gets.
And then you'll see that. Wait, hang on.
It's darkening.
It's darkening. But if we get more and more and more and more,
okay,
it becomes
more and more. It's darker and darker.
It's darker and darker and darker, and you can see my open source contract, my open source software, not contract, and the overall way this stuff works.
I mean, I would say in general, basic theoretical computer science stuff, as soon as you've injected any non-trivial amount of opaque execution, you make an external function call in the sort of language of that space, you can no longer make any guarantees about overall program execution. And the amount that's required to get to the I can't make any real guarantees anymore is very small. Non-trivial is a technical term. It's not me being derisory, so people can go read John Savage, Theory of Computation, 1998, if they want. That's a great textbook.
So why is this concept important for our crypto listeners? Because if somebody tells you that something is non-custodial / open source, but then there are key functions which require calls or reversions to closed source software, it also means there's no way for us to know for sure what's actually going on. Sure, and this is to go back to John's explanation about binaries. Sure, we can see that this order was executed in this sequence and this, but how do you know that that specific route that you chose that was executed didn't have to go through a whole bunch of processes?
There could be logic paths.
There could be logic paths that you're not aware of that allow this one to go through, and then the next one doesn't go through, and that's why you may get inconsistent results, so to speak, because you just don't know how it works.
And it's also not fair to say that the code is out there and somebody can find it and verify it, because in general, the code is always out there. I mean, Microsoft's products, Apple's products, whatever, are all closed source. They're on computers inside Microsoft and Apple, and for all we know, they're published in some guy's blog, which they haven't found yet. Right? That's not that they might exist, even that they might exist on GitHub somewhere. You don't really qualify as open source in any meaningful sense unless a user can look at the system and be directed to where the code came from, because reverse engineering how to build a system, as anyone who's built large software before will agree, reverse engineering how to build a complex piece of software is extremely challenging. It can be challenging even given detailed instructions. But finding the code in the first place is essentially impossible, because you're looking for the code that matches a binary blob that's, the X-Files style. It's out there somewhere.
That was just what I was going to say. I mean, like, if you're going to say that this is open source because the code is out there, then we're taking on a Mulder and Scully kind of thing and say that, well, the truth is out there. Sure, but
the truth, actually, the truth is out there. Yes.
The truth is out there.
And surely
okay, that doesn't help me at all.
The code exists on a computer somewhere, unless there were no backups. Right. Fair enough. That's a theoretical possibility.
This is extremely important to understand. We're not going to refer to any specific ongoing litigation. But
this is a thing in a lot of projects. There's an awful lot more closed source infections of projects than people appreciate.
This is something that we should be cognizant of, because this is going to be a recurring theme in the weeks and months to come, because it is quite painfully apparent to me that the government finally understands this concept.
I will also note for any aspiring sleuths out there that you will run into closed source contracts and public explorers that were published by the deployers of widely used services. And in some cases, those must have been mistakes or whatever it is, and they're never interacted with again. And so it doesn't matter, right? People make mistakes. They publish the wrong version. Whatever. They forgot the keys to... Doesn't matter. In other cases, they're published and they are interacted with repeatedly. And the problem is, on Etherscan, you can't tell. Because if Etherscan says there's no token transactions, internal transactions, or transfers, it doesn't mean the contract wasn't interacted with. So you are absolutely not able to tell from Etherscan and from a lot of other public explorers whether a given binary blob contract without verified source has been used ever, heavily, or not at all. Etherscan does not provide users with that information. So you're going to have to go, we've published stuff with links to various whatever, or you can run the stuff yourself and decode it on your own, because clearly that's the most efficient way to do a lot of these things. You can't make those determinations, so going and finding, this deployer of a project published these 6 blobs, that is not sufficient for there to be any issue of any sort. So you need to do more. And I think people don't realize that, once again, Etherscan and most of the other major explorers for many chains do not provide you with this information.
Well, to be fair, it's not their responsibility to do so.
They're tracking transfers of assets and various types of function calls. They're not tracking all types of function calls.
Take your lumps. Finally, let's talk about WazirX. Sorry for the loss. And wallet compromises.
I guess that deadpan delivery is a good tribute to Bob Newhart.
There you go. And wallet compromises. Okay, so what do you have to say about that?
We don't know exactly what happened with WazirX yet.
Yes.
A bunch of money
We know the money's gone.
This morning our time, last night our time. Whatever,
Something
in
like
the
that.
last half day or so.
Yeah.
Last day, our time, as a publication maybe. There was some suggestion this might be a wallet compromise. Okay.
Okay.
We don't know. There was even some Twitter speculation about like what wallet generated the keys for this. I mean, no clue. Various blockchains may be infected. Who knows? So I think there's two important things to note here. One is the techniques that were used to launder, such as it is, the money and what those were achieving. We can definitely learn things from observing those techniques, or we can note things about the world that people should have learned already. And we can talk a little bit about sort of wallet key generation and the whole wallet process. There is a long history going back more than a decade of wallets that generate keys in ways that are not as random as they should be and may or may not have various exploits available to them. There is widespread public reporting of a number of incidents in which very old Bitcoin keys were cracked because the wallet that was used to generate them didn't do them randomly and didn't they were not generated randomly over the entire space of possible keys. They were generated randomly over a tiny subset of the space of possible keys, and the non-randomness extended further to patterns in the way the keys were generated that would allow a search space that's tractable. A search space that's tractable means not your keys, not your crypto, but also your keys and still maybe not your crypto. Right? Because if somebody else can guess the keys, it's no longer your crypto. And that's been a thing that's going on for a long time. There's a fair amount of historical wallet transaction activity attributable to this sort of thing, and the people involved in that are obviously fairly well resourced and organized and have been running long-running operations that, can extract and move around old keys. So you wouldn't expect, oh, wow, I found the keys, straight to Coinbase, sell. That doesn't make any sense if you're running that kind of thing for a long time. And there's pretty clear evidence in the public data that there's a fair number of these operations running. And you see reports from time to time of this stuff. Fine. So that these people may or may not have used a wallet provider that had a flaw is not hard to believe. We don't know who the wallet provider is. I'm just saying there's a long history of flawed wallet providers. It's a bit like saying, a European car company lied about their diesel emissions. Yeah, I find that believable because there's a long history of European car companies lying about their diesel emissions. Yeah, you can Google that if you don't get the reference. Also, they may just have a standard old, phishing attack, or somebody made a mistake or hack. We don't really know, but it's worth noting that. The second thing to note is that in this case, some of the funds that were involved in the operation were passed through Tornado Cash, and Zach XBT managed to de-anonymize the Tornado Cash transactions very quickly. He's a very capable investigator, but he's not the NSA. And anyway, supposedly the NSA can't trace through this zero-knowledge stuff if it's used correctly. And the point here is not to denigrate anyone's skills. It's to say the purpose of using Tornado Cash here was not to achieve real anonymity. It was to outrun the bandwidth-limited blacklisting processes that exist in the space. Right? So if you can run your stuff through Tornado Cash, it takes some amount of time. And Zach is getting really good at this, running these timing. He's getting really good at this, and it's quite quick. But he can't do it in 30 milliseconds, right? That's probably not ever achievable. And anyway, getting people to block accounts quickly is further challenging. And as long as you've got services that will accept funds out of fresh addresses that were funded out of Tornado Cash, and you can push transactions through quickly enough, there is no way to stop this without switching to a system that is whitelist as opposed to blacklist. This relates to the closed source, open source conversation in that automated validation of these types of smart contracts is, in general, impossible and certainly extremely time consuming. And there are reasons for which it can never be made fast. This is not a theoretical computer science podcast, but it's going to be challenging. Anyone that's familiar with recursive enumerable language acceptance by Turing machines, if you know what that phrase means, you understand exactly what I'm referring to and how outracing the bandwidth limited blacklisting process is very achievable as long as you're able to publish mixers. Relatively complicated code. So what we're learning here is not, it could be North Korea, it could be whoever. We have no idea. It doesn't matter who. What we're saying is
could be your grandma.
That observation has always been true.
Yes.
And for people who understand the way the computer science works, that observation has always been relatively straightforward. And it's been clear that this is the correct way to perpetrate hacks and exfiltrate the results. Always. And so I would not say using that technique means it's the same attacker, because any attacker that knows what they're doing, and let's
Would
be
do
honest,
it-
at this point, the major attackers
Yeah.
all clearly know what they're doing, would do it that way.
Yeah, exactly. And that's one of the things that I would be hesitant to, unless.
Oh, there's other information for
Yeah.
which you could make these attributions. So we're
Correct.
not, we.
So
we,
if you have information leading to the identification and arrest,
all right, yeah. Anyway, we're not. Yeah.
so I mean, but if
This isn't Crime Stoppers.
if you have information outside of just looking at the blockchain transactions that tells you that this is
Well, there are plenty of ways to figure it out. Like hack the guy's camera, and you know who
yeah,
it is,
yeah,
like, whatever.
yeah. But if all I'm saying is that if you're just looking at the transactions themselves, yeah, it could be anybody.
They're doing it correctly in a way that is,
Could be your grandma, could be my grandma, could be his grandma, could be anybody.
neither of my grandmothers would have had the. Although they were both totally fine on the email front, they would not have been able to pull this one off.
So,
Although one of my grandmothers would have found somebody if she cared enough.
all I'm saying is maybe don't be so quick to ascribe blame to any fine people.
We don't think that these patterns themselves
Yeah.
are sufficient to make those types of attributions. These patterns are only sufficient to attribute this to someone who knows what they're doing.
But if you have
There's more information. We're not,
But if you have information that would lead one to believe that it is a specific actor, we'll be open to receiving that
Well,
information.
okay, whatever. That's not fine. This is not. Yeah.
Anyway, thanks for tuning in. Hope you guys had a good time. The prompts were okay, but I think the ink was probably not dark enough. We could have spent more
Too
time
much
with that.
water in the glass.
Yeah, that's what
The
it
glass is more than half full.
was. There you go.
Positive note to end the podcast.
Okay, so on that note, thanks for tuning in. Thanks for watching. Thanks for listening in for wherever you get your podcast from. We appreciate all your comments, your likes, your subscribes. We appreciate you guys engaging with us on Twitter. We enjoy that very much.
Maybe comment more on Twitter or DM or whatever as opposed to YouTube, because clearly
The AI who's watching the YouTube comments will be back. I
it
assure
actually
you of
AI?
that. No. So, anyway, thanks for tuning in. You guys have a great weekend. Have fun out there, and we'll see you again next week.
The truth is out there.
Well, something's out there.